And we are live. So, hi, everybody. We are back for another great construction technology webinar. And today we're really excited to have our guests, Matthew and Ryan. They are absolutely passionate about the topic that we are going to discuss today. So, you guys are in for a real treat. So, without further ado, I'll turn it over to them to give a brief intro and we'll dive in. So first, starting with Matt, take it away. Give us an intro to yourself.
Hi, thanks, Aaron. Yeah, my name is Matthew Lopez. I'm a business development executive with Specto Technology. I've been involved in the instrumentation and monitoring industry for almost 10 years now, with experience on the consulting side as well as the hardware software side.
Fantastic. And then, of course, Rayanne, let us know
Thank
a
you.
little bit about you and what you're working on.
Yeah, so I'm Ryan Chamas. I'm a senior project manager at GZA. I'm with a digital technology solutions group. I've been a PE and geotechnical engineering in Massachusetts for the past 7 years, and I've been in the industry for 13 years now. And my team and I, we specialize in automated instrumentation. Deep foundation testing is one of my other specialties, noise monitoring. We do some cool stuff with drones, LiDAR, photogrammetry. We also do satellite data, and my larger team does some uh, design, such as supportive excavation and so forth. So typically, what we do, we're the boots on the ground. So we go, we install the systems, whether it's on the ground or in the water, even,
Mhm.
and we monitor everything remotely. And we're consultant engineers mainly.
All right. So we've got a lot of topics to cover today. So let's get started. And actually, before we do, so for anybody in the audience, please do feel free to use the comment box or the chat box to engage with our panelists today. Please ask questions or leave any comments or thoughts you may have. So we do get to your questions. We love to hear from you. So use that comment and chat box as needed. All right. So both of you kind of mentioned a lot of different terms, but let's start out with the basics. So, what is monitoring? And I guess like what is asset monitoring? What's some of the history around it? What is this whole part of the industry?
Rayanne,
Yeah,
I'll let you take this one. Go ahead.
thank you,
Yeah,
Matt, my
of
friend.
course. Yeah.
To me, asset monitoring is really tracking the movement or the status of an asset, whether it's structural, geotechnical, whether it's even wildlife or underwater. So it is the monitoring of, let's say, deformation, vibration, noise, loading on members, such as stress and strain. There's dust monitoring. There's weather monitoring. You also want to monitor the level of pour water pressure in a dam, for example. So, to me, monitoring is really keeping an eye on the existing features and also keeping an eye on um, adjacent features. Let's say you're working next to uh, railroads. You want to make sure the railroads are not
Mhm.
affected. You're putting a support excavation next to a high rise. You want to make sure that the adjacent structure is not getting too much vibrations. The people living in it are not getting excessive noise. The workers are doing it safe, so they're not they're following OSHA, and they're not being you know exposed to too much noise or
Yeah,
dust. So
yeah.
all of these, it can be environmental, it can be geotechnical, and there's no limits really.
So what I get from that is it's really just another form of reality capture to
Mhm.
make sure we're staying within safe limits for various things.
I totally agree, Aaron.
Yeah,
All right.
absolutely. And there's some other terms that you'll hear thrown around within the industry, structural health monitoring, remediation monitoring, or even when you get industry specific, when you go, tunnel monitoring, mine monitoring, dam monitoring, but they all revolve around the same concepts.
Okay. Awesome. So, take us back to the beginning of this type of monitoring. So we've obviously been building and doing construction since the Stone Age or before, right? But we didn't used to have these fancier tools. So take us through a little bit of the history. And I know, Ryan, You definitely have some of this down, so I'd love to hear from you on this.
Yeah, sure. I agree that it started probably with when humans started building structures. They
Mhm.
noticed, oh, they started moving. So that would
Mm,
have been the most basic monitoring is just seeing, hey, my house, I built it, started moving. But really going to advanced, especially from a geotechnical aspect, that's where my background is. I would say it starts with Carl Zaghi, who is the pretty much the father of geotechnical design, because he started
okay.
paying attention to the design, the bearing capacity of soil, and also estimating the settlement of foundations. So when that study started evolving, the need for monitoring those, the water pressure and the settlement and movement of foundations became more important. So he was around in the 1930s, right? And then he eventually ended up at MIT in
Mm,
Massachusetts. And from there, he had a couple of mentees, Ralph Peck and Casagrande, which my GTech fellows would probably know both names since Ralph Peck was really all about the case histories. So he was
mhm,
paying attention to the dam failures, saying, let's learn from all these failures. And then you have Casagrande, who many know him for the soil classification system. Everybody uses it on a daily basis. But what many people I think don't know is he actually kind of pioneered piezometers, which is monitoring the water level using piezometers.
mhm.
Created, but he pioneered it in geotechnical engineering. So I think that's around the 1960s when that type of monitoring started being more popular. And from there, Ralph Peck actually had a another mentee of his, and he's known for his Red Book. So a lot of people in the instrumentation industry know the Red Book, and it's John Dunnicliffe. He wrote it in 1988, and he was really affected by Ralph Peck. So and it all goes, mainly it's through MIT.
Okay.
And not many people know that John Dunnicliffe actually was one of the partners at GZA. So he worked with Goldberg Zoino
Oh,
back
whoa.
back in the 70s
Yeah.
decade, and he founded our group, the Soil and Rock Instrumentation. So
Okay.
he wrote the red book that kind of his main point from it was don't just throw out instruments. There has to be a question, and if there's a question, then answer it with a instrument that you're going to monitor. Do not just throw instruments if there's no question there. And he
Mm,
also recommended putting piezometers, routing piezometers in. But
yeah.
that's the history that I know.
Amazing. I didn't know any of that. So thank you for that little history lesson. I think what I'm also relating to, so for a lot of the software discussions or other types of technology that are more digital, we always talk about, well, you can't manage what you can't measure and you
Mhm.
need to have data. But, there's obviously the whole physical side that we're living in. And all of that history that you just described is basically helping to measure the physicality of the world around us so that we can then manage it better. So, wow.
Absolutely.
Yeah, we've come a long way. Matt,
Sure.
anything to add to
No,
that?
I mean, Rayanne nailed it. I mean, as far as the history goes, when you look at it from a technological standpoint, the amount of advancement from that time is really kind of the benefit of conversations like this, where we get to talk about, yes, where it came from, but also where are we going. And I think that's
Mm,
just as important as understanding the past is also, what our strategies are going to be involving the future, how a lot of these tools work together. When you think about a lot of the things that you've done webinars, previous webinars on,
mm,
it's always understanding the right tool for the right job. And I think that
exactly.
that lies in truth, right? So that's been the way forever. So really understanding how to leverage all these tools from, the forefathers of this industry into where we're going into now, kind of this new digital era of really maximizing those tools. It's really a great part of this conversation. I think that's really what's important.
All right, let's keep going. And I do see that we have a few more attendees on the stream. So great to see you guys. Thanks for tuning in. And just a quick reminder, do feel free to use the comment or chat to ask any questions or share any thoughts or comments. So moving on to the next question or on this topic that I have. So we know that we do monitoring in construction. and a lot of AEC type related activities. What other industries or teams might be doing monitoring that we're not aware of?
Yeah, so I'll take this one.
All right.
We see it in a lot of industries. So the applications that exist for all of this type of instrumentation, and even when you talk about the type of engineering teams that are requiring this type of monitoring, I mean, it goes really wide. So mining being a big one, any
Mm.
type of critical infrastructure, dams, bridges, things of that nature, all utilize this type of monitoring. You can get into oil and gas. So the technology actually has such a widespread application that you don't see it specific to any one industry, right? We have clientele that on dam sites, and then vice versa. You go to someone who wants to monitor noise at a concert venue,
Oh
right?
yeah,
So, yeah, so it's
yeah.
just the application for all of this technology is very wide, and there's still a need for not standardization, but honestly utilizing the correct functionality of each of the sensors for what they're trying to monitor specifically.
Gotcha. So all the way from building buildings to having fun at a show and being
Exactly.
entertained. Yeah,
Yeah,
we're
I
surrounded
totally
by
agree.
these
And
activities.
I've also been seeing it, with wildlife. So we have certain use cases where, we've used drones to track wildlife
Mm.
with the assistance of AI. And we also put automated instrumentation in the water. So we're automatically measuring dissolved oxygen and turbidity and pressure and
Yeah.
flow. So it's really it's endless nowadays with monitoring, especially in 2025. Almost every year or two, something new's coming out.
Mhm.
Now we're even
Amazing.
monitoring acoustics or noise underwater. So a bit of everything, and also inside when you're inside a building, you can do some impressive lidar scans, and you can monitor that way. Monitor where your mechanical equipment is going to go, but also monitor if there's any movement at the same time.
Got it. So that leads me to the next topic, which Rand, I think you described like the piezometer in the beginning, right? But we've evolved over time, and just now you mentioned like drones, and like we're doing all sorts of different stuff now. So, what do the current monitoring technologies look like? And like specifically with some of the more I guess, relevant or current use cases that you mentioned, like how have they evolved?
That's a very good question, Aaron. So we used to go and place a vibration monitor, look at the piezometer, do everything by hand, and babysit these instruments and get the data, go analyze it in the office. Those days are almost long gone. So now we set everything automated, so you can monitor a full dam. Inclinometers, you're measuring the inclination. Piezometers for the water level. You can put extensometers, and you can put strain gauges, settlement plates. There's so many different types of
Mhm.
monitoring capabilities, but now we're doing everything automatically. But you still, of course, need to understand the basics. And an example, and we're seeing AI kind of coming in
Mhm.
equations. So, for example, we've been, I have a couple of large projects where the community noise is sensitive next to whether it's demolition or
Yeah.
construction of piles. So we've been setting these with the help of my friend Matt. We've been setting these automated noise monitors that record the sound wave, and then using AI, it'll take the sound wave and estimate what the source is. So it'll tell you it's a dog barking, or it's a car, or it's actually construction, or even if it's a helicopter. And it's pretty amazing where we've gotten to, where
Oh.
now you don't get lost in the data. Now you get the data that really matters with a level of confidence. It shows you actually, it's due to construction or a train, and it gives you
Mhm.
low confidence, yellow confidence, or green. I'm really confident it's a train. Uh,
Yeah. Yeah.
yeah,
I'm thinking like I'm in LA, Southern California. We have earthquakes. Sometimes you wonder, like, oh, was that a shake from an earthquake, or was that just a really big truck driving by?
Yeah.
So I would. love to have that at my fingertips. But
And I think
yeah.
in the same breath, it's really kind of broken out into two major categories. Our
Mhm.
sensor technology has advanced quite significantly recently, but then the automation technology is also advanced as quickly. So it's really I almost want to say almost like an arms race of, okay, what sensor does what, and now how
Mm,
do we automate that sensor? So you have your sensor manufacturers really starting to push the capability of these sensors, having multi parameters, having them with wide sensitivities and accurate data sets. But then, how do you automate and manage those? So often you'll see that those two markets are segmented, but they work hand in hand all the time. And you have companies that focus on the automation, you have companies that focus on the sensor technology, and then also companies that focus on the software. So it's really bridging the gap between those three sectors on maximizing the capability and the efficiency of folks like Rayanne or construction managers,
mm.
engineers to really leverage all of those technologies to give those answers to their end clients.
Yeah, that leads me back to whenever I get asked, like, "Oh, Aaron, what technology are you excited about?" I'm like, "Oh, it's not really one specific one. It's the potential and opportunity for them to integrate and sync with each other and talk to each other and basically give us more information um, together than we would have gotten with like any one piece." So,
No,
Yeah,
yeah.
absolutely. Yeah,
big
being agnostic is a big strategy for a lot of the folks who are
Mhm.
heavily involved in this. They want to have the maximum capability within house to be able to utilize whatever tool they feel is best.
Right.
And, that's being a primary focus. And you see it in the software sector as well in
Mhm.
construction, right? Like you said, being able to integrate multiple tools into one platform, being able to leverage multiple types of data sets into one place so that you don't have to go to multiple sources to try to figure out the issue. It's really something that we're seeing start to be brought into the monitoring industry as well, and I think a lot of folks like Rayanne strategize around that and being able to leverage and harness the power of all these sensor technologies that are coming out.
You're absolutely right, Matt. And it's big kudos to the developers, the hardware developers, the vendors, and the software developers because there's so much data now that we're getting, and really being able to take all that data, have one platform, being able to automatically uh, alert and report our clients on that. It really allows us to leverage the right instruments for the right problem, for the right client and project. And we're empowered by the availability of such innovation. And every
Yeah.
5 years, I see a next step, a big jump in what we can provide. And automation
Gosh.
has been the big thing right now.
I feel like it's every 5 weeks at this point that something new, especially in the AI category, just takes a big leap. But
Yeah.
we're
And
we're living in exciting times.
And now what we're able to do is we're getting live monitoring of the data. You used to have a surveyor go shoot the points, once a
Hmm.
day, let's say. Now you have automated systems that can show you the water level every 5 minutes if you want. You can have the deformation monitoring every half an hour if it's really sensitive. The vibration is just continuous, so it's no longer just set for a piece of time here and there. You're getting a continuous monitoring product, and you can also tell, okay, look, the temperature, this bridge is moving with the temperature fluctuation. So really, the quarter inch that we said, oh, is going to be absolutely terrible, is actually just a natural frequency of the structure. And I feel like in the future, maybe, Matt mentioned it, is the health monitoring of a building or structure. It could continue past the construction period, and it could be, I can just set some sensors and they can stay there for many years to warn you about any
Hmm.
movement or something that is abnormal.
So I have kind of maybe a fun question, but what's the size of these sensors? How big or small are we talking here? Because I'm just really
Yes.
curious. Yeah.
So you can go from very small, fits in the palm of your hand, to a really, when you talk about a inclination sensor that comes on a reel and it's really
Hmm.
long, then takes like a crate or thing to be shipped. But honestly, it just depends on what parameter you're trying to monitor. So
Gotcha.
depending on the parameter will dictate how large that sensor is. But it does vary. I mean, like some of these sensors are tiny. You know, you start to talk about vibration. You know, with the advancements of the technology, the sensors are getting smaller. So that is a benefit. You look at an old seismograph, probably Rayan remembers, you know, how large that seismograph was, and the supporting equipment to automate it back then was even larger. Right now
Hmm.
that
I
we
have a
have,
multiplexer right there. It's a really old one up top.
Yeah.
You can't see it very well, but that one's this large. Now a multiplexer is probably, just this big.
yeah,
And, strain gauge is always small, but everything has definitely been smaller, especially when it comes to loggers, which is
Yeah.
fantastic. And one big thing with the advancement that I really enjoyed in the past 10 years, you don't have to run wires, half
Uh-huh.
a mile or 500 feet or 200 feet anymore. Everything's wireless. You have the LoRa technology that's come around where you can reach, miles, many miles from where your gateway is to where your sensors are. So you can monitor a whole valley with a
Yeah.
single gateway. And I think that that really pushed us to becoming more efficient and even cost effective.
Yeah. Wireless is a game changer, I think, in pretty much all aspects. So thanks
yeah.
for
When
pointing
you
that
look,
out.
I think when you look at that inflection point of, you know, when automation started to become very popular, the automation equipment was expensive. So there was an initial, you know, cost to be able to automate. Now that the technology is where it's at, it actually is more efficient, is more cost effective to wirelessly monitor a lot of these items versus the risk of running, you know, miles of cable or miles of trench work for whatever specific type of project. So it's
Hmm.
very nice to see that the capability of the technology is now matching the cost efficiency and helping folks be able to not have that burden of costs whenever you try to instrument multiple projects.
Mhm.
So, so far we've talked about like all the best practices, I would say, or, the history of where we got to using good monitoring practices. But sometimes we don't always get it right in this industry, which we know there's always challenges. What does a poor quality monitoring situation look like, and like how would a team know, like, oh, hey, this sensor, this monitoring solution isn't the right fit, maybe it's not working so well, and how do they fix that?
Yeah, so sometimes no monitoring is definitely when you need it is the worst thing you can do. So
Uh,
sometimes
yeah.
some teams might say, "Oh, I want to save on money, so I'm just going to use a vibration monitor here. Let's cut out all of the rest." And then the risk is obviously a failure happening. It might not always happen, but you definitely want to mitigate it. And instrumentation is kind of adding a factor of safety to your design. So you
Hmm.
design it with a certain factor of safety, and just having instrumentation gives you um, confidence. Okay, this is going exactly as I expected. Especially in geotechnical engineering, there's a lot of unknown. So you do a few borings here, so you have an idea of a general idea of what the soil is like, but then you go to build a huge support excavation, and you're like, oh, actually, the soil here, is liquefiable, or it's, not well graded. So then you end up with some issues. So you want to get that warning system, and that's where instrumentation is important. So if you don't use the right instruments, you might end up with a failure that can be very costly. And to me, setting up a few, instruments out there to save a life from
Hmm.
catastrophe is totally worth it. And historically you've had lots of dam failures, whether it was in the Champlain Towers in Florida that just happened in 2021, where unfortunately almost 100 people lost their lives. That was bad design, yes, but also if there was some sort of uh, inspection, and after the inspection they found something that they monitored it, they would have been
Hmm.
able to say, oh, in that case it was a pool that was undermined and eventually caused a collapse of the apartments. So things like that, whether it's dams, and then Hurricane Katrina came not too long ago and showed us what real damage can happen when you have assets that are not properly designed, but also perhaps if we had used technologies like INSAR. So that's one thing I wanted to actually touch base on. We use
Yeah.
satellite data nowadays to look at the difference in features. So what you can do, this is one of the coolest technologies nowadays. It's the only one where you can go back in time, and so you can go back 10 years and say,
Yeah.
oh, this hill has been experiencing a landslide way before we even noticed. And that's all good information, whether it's for wildfires. In
Hmm.
California, you can say there's been a drought. Look at all the weather data we have. And but now with NSAR, I've been seeing use cases where, let's say, there's a construction next to a old uh, building that's already
Hmm.
not in good condition, and then they say, "Oh, the construction caused this." But then you can go at INSAR, look 5 years back. You can look at almost a biweekly frequency and say, "Actually, no, it's been moving before the construction even started." So it's
Wow.
amazing where the technology has taken us in terms of INSAR, in terms of AI, and the future has a lot to come.
Yeah. So my takeaway there is, especially for construction teams, um, it's really, we can think of it as a life saving measure, risk mitigation. I liked how you said, like, yeah, it's a more factors of safety to
Right.
your project, whatever it is that you're doing. So
I've personally had a
really
few
good use
projects
cases as
where
well.
you see the data. Sorry
Yeah.
to interrupt you. That we've seen
No, no.
some data with the track monitoring, and you start seeing some movement, and you go to warn the contractor. They'll stop work, and then all of a sudden, the ballast starts to give way. So,
Mm,
oh, thank you for letting us know. Same thing with movement of retaining walls. So there are examples where we were able to alert the team before something worse could have happened, and I think there's a lot of value there.
yeah,
And
yeah.
it really circles back kind of to your point, Aaron. It's I
Mm,
think a main takeaway of understanding instrumentation, and even like you said to the original question, if you have bad instrumentation, this it's really understanding the why. Uh, that's a
right.
big thing with the instrumentation. It's like, yes, I can automate this, but if you don't understand why your sensor is doing something or why it might be reacting that, understanding the why, I think, is the most important factor of instrumentation as a whole.
Absolutely. And that why question, or needing to understand the why, comes up in so many different aspects of all that we do. So it eventually ties back to, people, process, technology. So
Yeah.
why are we doing this process? Why are we using this technology to complete this process? Why does it relate back to people this way? What are our people getting out of this? How are they
Mhm.
affected?
Yeah. Yeah.
And that's
100%.
what how innovation comes about. It's you ask a
Yeah.
why, and you say, "Oh,
Yeah.
this doesn't exist. Let me create a wireless system. Let me integrate AI." And this goes back to the previous question you asked,
Mhm.
Aaron, where where is it going? And I'm
Mhm.
hoping to see. I don't think it exists yet. There's a lot of innovation happening right now, but I would imagine tying in the design with the instrumentation so that
Yeah.
you have the design live in front of you and you have the data that's live in front of you. So as things are moving, things are changing, hopefully it would be able to cross into the design of, we're doing
Yeah.
a lot of finite element modeling, a lot of BIM modeling. So all this data exists, but I think the future is what do we do with this huge amount of data? I know we've been working on a lot of data centers at GCA.
Yeah.
So we're working on empowering AI, and hopefully it'll come back and empower us very soon.
All right. Love it. So, let's see. I want to talk about some more practical use cases, which you guys have both teased out some really interesting ones so far. What else is out there? What are some maybe other unexpected applications of monitoring technologies?
I
So
can,
I'll take a couple off the start. So because of the type of company Specto is, we are offered the opportunity to solve a lot of issues or a lot of instrumentation questions for clients, and we do get some weird ones. So there are some very interesting applications, and I think it goes to kind of kudos to everybody who's thinking open mindedly of like, hey, how can I use this sensor to help me understand what's going on with this. But one of the more recent ones is, someone was asking for vibration monitors for, the medical equipment inside of a hospital, right? So you talk about the sensitivity of MRI machines, CAT scan
Yeah.
machines. They really wanted to understand kind of how or if those machines were being impacted by vibration in the specific area they were in. So that was a really neat one, and I think there are a couple more with the advancements of the automation technology that exists where they can do these live readings of, okay, we understand that this structure is under duress. We understand it's moving. We need to understand the rate of that. The technology exists now that can actually kind of sample at a rate that is very significant, multiple times a second. And then when a specific alert is triggered or a specific threshold is triggered, it can notify you of that change almost instantaneously. So
Mm-hmm.
there's some really cool applications as far as that type of technology goes, where it's sampling at a rate that is significant, but it's not overloading your database, and then it'll tell you, early detection, early warning system of telling you what those
Yeah.
changes are when they actually occur.
You got my attention at multiple times a second, so this is pretty fast.
Yeah, super fast, and it's not even the fastest it can be. We could really
Mhm.
go down the rabbit hole if we wanted to talk about dynamic structural monitoring, where it is hundreds of times a second when you're trying to understand the amount of strain and the impact of any type of change around the environment to impact that structure. We have partners who do this on the bridge level very significantly,
Mhm.
where they put these dynamic monitors on a bridge that are going hundreds of times a second, and they can really show you excuse me, they can really show you what's happening as each car passes by.
Hmm.
Yeah, you understand the strain, you understand the force that's being applied to that bridge instantaneously as a 18 wheeler passes by, as a standard size car passes by. So it really helps you understand the true health of that and what that actual structure is going through from a strain perspective when those regular day
Mhm.
activities
Mhm.
occur.
Gotcha. So, I also want to give a brief reminder. We're a little more than halfway through, so for the audience, do feel free to use that comment or chat box to leave any questions or thoughts. I want
I
to
can I
go
can
back to
continue on that.
Rian. Yeah, what interesting
Yeah, I've
applications have
had
you
similar
seen?
one to Matt. Actually, you were saying about the lab equipment, and sometimes it's actually the lab animals as well. So you do the noise and the vibration for. They're very sensitive. Apparently, they start acting weird.
Mhm.
But other things I've heard of is actually noise monitoring on space shuttles. So there are some of
Oh.
the noise monitors that we're using. They're uh, putting them on shuttles just to see what the ambient noise of the equipment is, and if there's anything that's changing. I thought that was fascinating. We've also
Mhm.
installed the inclinometers on slope faces down to 300 feet and more. And I think, back, 10 years ago, you would not have been able to automate that. And that goes back to the vendors and the innovators really pushing the technology. So that's another really cool application. And other things that we're actually doing are a lot of coastal resiliency, drone photogrammetry work, where
Yeah.
you fly the drones. You have fixed wing drones or the usual propeller drones, but you fly them next to the coast, whether it's on the mainland or on islands, and you can monitor the change in the coastline. You can monitor the houses that are right there. As everybody know, I think coastal resiliency the past 5 years has really come up. New York is doing a lot of work there.
Oh,
I know
yeah.
Boston's doing a lot of work there, and of course you have New Orleans and even Norway. So that's I feel like there's a lot of the technology is shifting towards aerial photos and bathymetry scans and lidar that is giving us some new data that allows us to mitigate the risk of flooding, the risk of undermining structures, and even hopefully in the future maybe we can mitigate tsunamis. Who knows?
Yeah. Yeah. Wow. Okay. So there's so much to unpack here.
There
Oh
is.
yeah.
Um, I want to maybe see, Ryan, I know you have a couple slides that you may have wanted to share. Would
I
now be a good time, or
Yeah,
want to make
absolutely.
sure we have some time before?
Yeah, I was just
Mitigation
going to
has five.
share some samples of the technology we use,
Yeah,
kind of the
since we're
show and
talking about
tell
use
since
cases and
we're describing it a lot. Uh,
yeah.
Let me know if you see the right screen. Do you see my screen now?
Yep, we
Yeah.
can see it. Hold on one second. There we go.
Great, as long as it's not the presenter screen. So these are just kind of samples of what we do. This is an inclinometer that we're talking about. Actually, this is a shape array. Really cool technology where we used to just send one sensor down and up and tell what the inclination of the ground is. This is our team installing one down in New Jersey. And this is a sample of the automated toll station where we use them on tracks. We use them monitoring residential buildings, commercial buildings, anything, bridges, endless dams, all of it. So it's it's really cool technology where you simply just attach it to a brain which has a modem in it. You attach the total station that a manual server usually uses, and you're good to go. And it's reading continuously, letting you know, warning you instantly within minutes of
Mm,
taking a reading that, oh, something's moving. This is the down here is deep foundation testing, so we're actually
yeah.
monitoring the temperature of the concrete wirelessly as after they pour this huge foundation for a bridge, for example.
Yeah.
Based on that, we can do a 3D model and assess the integrity of it.
How
So,
deep can you go
uh,
wirelessly?
the depth with these are it's called tip thermal integrity profiling, and we've gone more than 150 feet. But
Oh, cool.
you have the capability to go down even more to 250 and even more. The design is the limit.
Mhm.
And I like this one here. That's just a one of the bridge projects that we've had, but really you can see the fluctuation with the seasons. So you can see that it's a steel bridge. You'd think if it moved, a quarter of an inch, that it might be a terrible thing while you're doing construction, but in reality, it's moving with the temperature over time. So you would not get this
I
level.
think we're on maybe a different slide, Ryan.
Oh, sorry,
Um,
not see it now.
maybe.
It might
Or it
be.
could just
Yeah, it didn't change. Yeah.
be me. Yeah. We're
Oh,
on
sorry about
two.
that. I'm gonna try to stop
Yeah,
sharing.
try resharing. I'm like, I see the images, the three images, but
I'm gonna try
okay.
sharing again. Let's see if it works.
Yeah, yeah, there you go.
Customize,
Yeah, there you go.
Does this
automated.
work?
Yeah,
Yeah, there we go.
there
There's
you
the bridge. Yeah.
Wonderful.
I'm like,
Sorry,
there,
this
that
is
looks more
moving
like a
with the
bridge.
temperature. So you can see that it's moving with the temperature as I was
Yeah, yeah.
explaining.
There we go. Awesome.
Pardon the technical difficulties.
No,
Uh,
all good.
Here's another example of a supportive excavation that we'd monitor. So we
Yeah.
can put strain gauges on the members to monitor the stress and the strain on the full members while monitoring the deformation. And usually we'd put vibration monitors on adjacent buildings. So this is an example of the data and
Can
a
you
rock.
go back one, Ryan? Sorry, I just want to bring up one more point.
Go
So
ahead.
this is a perfect example of what we were speaking to earlier of having those three categories of innovation.
Mm,
So here you have a sensor that is being automated and now bringing it into a software that now you can visualize and truly understand that high resolution data set, the benefit of monitoring higher resolution to
Mhm.
really understand what's going on here. This is a prime example of that. They have sensors specific to this use case. They automated it and brought it into a software for visualization. So now you get to see the full benefit, the full scale benefit of high resolution data versus if you were to spot check this, you wouldn't be able to correlate that environmental impact on this structure. You wouldn't understand, right? One guy goes out in the morning and does it, and then you have another data point in the afternoon. You'll see a big change and maybe freak out and be like, oh my gosh, this thing changed by this much. Now, since we are automating it, that high resolution data set comes in and it really gives engineers the tools to understand the why.
Absolutely correct, man. That's why we recommend a longer baseline period of looking at the structure to look at its natural movement before we start monitoring during construction. Very good point. And this is an example of a rock quarry. I'll keep going. This here it shows environmental, structural, geotechnical, spatial, even
hmm
mechanical applications of monitoring. Really, there's no limit to what we do. This is an the prisms that we use, the automated toll station. I'm going to move through them real quick. I'm just showing examples, really.
Yeah, no, I think the visual is helpful.
Yeah,
Yeah.
I'm glad. I'm glad.
Yeah.
And here are different applications of that total station we were talking about. You might be monitoring a support excavation here, multi-level railroad. Here we're monitoring the substructures of multiple bridges. They're replacing a ramp, and we were monitoring all the piers, the abutments, and adjacent structures. And over here is a retaining wall. And, you can tell it's in pretty much the
And
area.
this is a great set of pictures because it really goes to show how mobile this equipment is now versus where we came from. Right?
100%.
When if you were to talk about setting up a total station, completely remote, completely automated, self-sufficient power via solar,
Mhm.
back even 5 years ago, you would need maybe three or four more boxes than what exists today. Today, you have the sensor, which is the AMTS unit, the data acquisition device, which is the white box there that you see that will transmit the
Mhm.
readings from the sensor, and then the solar panel just to keep it powered throughout the duration.
So true. And you need a crew of two the whole day, every day, to get close to the frequency readings you're getting with this.
Hmm.
Right. And yeah, and I just wanted to show one quick slide here. I like
Yeah.
the comparison of the automation with the manual data. So this is an example of a project we've been on where we had manual readings, but then they're not as consistent, and then you take a break and then things start moving. The crew changes, your manual survey crew changes, and then you start seeing these weird movements that are not real. Whereas when you're automating, it's nice and consistent. And if something goes off, you can react really quickly and say, "Oh, someone
Yeah.
bumped that prism." Yeah,
Yeah, that made me think of with calculators, garbage in, garbage out,
right.
and humans
Mhm.
are prone to human error. That's just how we are. But
Exactly.
obviously, if you have the right tool in place, you're going to mitigate out those risks. So, yeah, this is a really powerful comparison here.
And
Um, um,
that's not to say, there's nothing wrong with a little validation.
mhm.
As we go into the world of AI, I know it's a big topic of how we're going
Hmm.
to use
Hmm.
AI in the engineering realm. Are we going to trust it fully and then come back and validate? You can still utilize that same thought process here, right? We're just validating what the automated instrument is doing. Do we like the resolution of the automated instrument? Of course. Do we need to validate? Yes. Do we still have to do those checks? But a lot of this will still come down to how do we be more efficient about that process.
Thank
Okay.
you. Yeah, I agree. And I'll just stop sharing. I think we've reached a good point, unless you want to keep going.
Actually, this is a perfect segue because we did just get a question from Dion, I believe. So, how do you sight in prisms when you've got an AMTS elevated on a support post or pillar?
Yeah, so we have multi-level prisms, and you can set your total station in two ways. You can either have it fixed, or you can have it as a free station. And really, what you need is your backsize and control points, making sure you have really good control points. At least, I'd say seven, but you need three minimum. But I put seven. So as you got to make sure that you're setting your total station properly, and you have a pretty good angle. So we have multiple of these total stations on that project. So we had multiple ones, one on this corner, one on that corner, and one on another structure. So we could cover the full support of excavation. So I hope that answers your question, and it's a very good question.
Sometimes you do got to get creative with the sighting and prisms, especially when you locate that instrument on an elevated plane or elevated platform. You got to bring in the truck. You got to bring in the bucket truck or however else you need to get up on there. But yeah, it's once it's set up, like Ryan, if you set up a good network, you'll get really good quality data out of it.
And typically we're using man lifts. We're going up there. You sight them by eyesight or by laser. Sometimes if you can't really access it, you can try to guess the coordinates remotely. I'll talk to Kyle from my team and be like, hey, can you try to shoot this prism? He's like, let me try it, and it becomes kind of a game of watching the laser until he hits it. It's pretty cool, and it also has an ATR field where it automatically looks within a field and says, oh, found a prism, and you say that's the correct one. So there's the technology is pretty impressive when it comes to total stations.
Oh, good. Great question. Great answers. All right. Thank you guys. So we're in the last 15 minutes or so here. Time flies by. And we talked maybe a little bit about like the safety aspect and why that's important. But just in general, with the industry's awareness of sensor technologies and specifically for construction, why else is it important for us to just know about?
I would
I,
say, go
no,
ahead.
go ahead. Go ahead.
Clearly super important, but
Yeah.
yeah.
I think you're reducing redundancy. You're not wasting time anymore, just going through nitpicking through the data, and you're most of your time is looking, at the Excel equations. Now everything's done
Mm,
automatically, and it's shown to you in a and after you confirm, of course, you got to know the basics and you got to make sure that it's running properly. But you're reducing the costs. You're using the right technology for the right application now, and um, you're avoiding um, just kind of getting lost in the spending hours and just getting lost in the small details. And
yeah.
I see that going with automation, and I see that hopefully happening in AI. But touching back to Matt's point, you got to know the basics, and there are some really brilliant people out there. Parts of ICGSM and DFI and all these different ASCE, all these great minds getting together and setting the standard. And I think I implore every professional, whether structural, geotechnical, mechanical, to join these committees. There are some brilliant things
Yeah.
happening, brilliant innovations, and I think as AI is coming in, it needs to be checked and it needs to be confirmed before just following it blindly. But
Wow.
ultimately, the awareness is important because sometimes you have a small contractor doing small projects, just cutting a small road and doing an
Hmm.
excavation without realizing it's pretty unsafe. And you
Yeah.
could have done some simple monitoring and avoided some big mistakes.
So a couple key things I heard there was, of course, improve safety. You
Mhm.
can have less Excel in your life, which I think we all want, and potentially, be a little bit better on our costs and our quality. So,
Yeah, I think a couple additional points would be not only are we increasing the safety of the workers of the project itself, but you also mitigate risk for your firm. If
mhm,
you're doing some of this proactively on your own when it's not required, and then an issue comes down the line, now you're able to defend yourself by having this automated data sets of saying, "Look, we were monitoring the entire duration of this project. You're telling me that this impacted, but I can show you how it didn't impact." So it really creates a safety net internally as well for your company and kind of the risk that your company is at whenever they're doing some of these, large scale projects or even small scale, but they might be more dangerous types of projects with impacts to the entire community around there.
yeah, that community lens on it all is huge.
Hmm.
Thanks for
Yeah.
Right,
sharing that.
right. It's an insurance policy. Really, putting the monitoring can
Mhm.
be considered an insurance policy, saying like you said, Matt, we
Yeah.
monitored the right thing. We used the industry standard. So really, what happened might not be caused by us. Good point.
And the
100%.
the contrast would be there too is, if you're at an asset owner and you want to say, hey, look, I think this construction project impacted my project. So now you have the other side of the story trying to say, hey, look, I have the data that shows, yeah, I was
Mhm.
impacted, even though you say it wasn't. So it really goes hand in hand. It is kind of odd that you can have both sides kind of going after each other. But I think if you have the proper data and you have the proper instrumentation in place to be able to tell your story, that's ultimately what's going to be able to help you at the end of the day.
Fantastic. Yeah, telling that story with like the
Yeah.
data, the real proof. Yeah.
Yeah.
Mhm.
Absolutely. So, getting towards the end of the conversation here, we talked about, the history of monitoring, how some of the technology has changed, but how about the regulation and the policies that come into play for construction, environmental, and other remedial industries. So with regulations and like having being required to monitor certain things, what's new or what should people know about?
Another good point, Aaron. I can touch base on that. I've noticed that, uh, you know, throughout my tenure, 10 years ago, they used to specify very simple types of monitoring for, bridge projects, DOT
Hmm.
projects, or Army Corps of Engineers. Army Corps has been pretty good overall because they always require the top notch, which is fantastic. And
Yeah.
so when it comes to dams, we've noticed that some have been evolving with the technology and requiring automation. Some will remain kind of stuck in time and say, "Oh, take manual readings of this and take manual readings of that." But I think through education, through webinars like this one, Aaron, thank you for doing this. As you're informing the owners, the asset owners, the governmental agencies, um, whether it's environmental, structural, or so on, that this technology exists and use it to your benefit. It's cost efficient, like we said before, and you get so much more data, and it's safer ultimately. And I think going back to kind of DOT work, now design build projects rather than design bid build. They're now the teams are capable of getting more creative through alternative technical concept. So you go in and they say, oh, instead of doing what typically is done, maybe we'll use this new technology, this new design.
Hmm.
And they're able to really innovate nowadays more than before. And I think, to your point, Aaron, yes, the regulations are evolving as the automated industry is evolving. And sometimes we even recommend other types of instrumentation. They might say, uh, I need to monitor this way, and we're like, this is not going to be very accurate, for because you're in the middle of nowhere, you don't have good backside control points. Maybe you want to use
Hmm.
satellite. Maybe you want to use GNSS, which is another thing that's related to satellite, connecting satellites to deformation. That's one of the actually latest, um, the more recent type of monitoring that's coming out. So
Okay.
Yeah,
I'm
and we
happy.
see it from multiple fronts. The construction side, the regulations coming in, but I think the regulators have done a really good job of learning from our past, right? So when you look at the age of our
Mm.
critical infrastructure and the rate it's deteriorating at, having these items into the regulation and into the requirements when they're designing and building, it's really starting to come up. You also see it on the environmental side as well, a lot more proactive environmental monitoring, whether that be air quality, dust, noise, that type of thing. We see it throughout multiple industries that the regulations are really starting to push the innovation and the need. And it's really highlighting the importance, to Rand's point, of webinars like this to educate and kind of get everybody familiar with the technology that exists, because a lot of people don't know that these technologies exist, and that's how they can comply with those
Yeah.
regulations.
Exactly.
Excellent, excellent point. So we're in the last few minutes for our audience. We can maybe take another question if anyone has anything out there. But to wrap up the discussion, I'd love to know what is one thing that you're looking forward to, excited about in the industry, and then also, two, if you can share, if people don't want to ask a question here live, where can they connect with you to follow up with you directly if they want to? So let's maybe start first with Ryan, and then we'll go to Matt.
Yeah, sure. Yeah, I can get nerdy about this. There's a new satellite that got released in 2024 by NASA. It's called the PACE, and it's going to be monitoring the ectoplasm and pretty much the ocean. Uh, so,
Okay, yeah.
yeah, and I'm interested to see what kind of data that's going to bring up, and I'm hoping to have open data kind of in the future. I look forward to more, governmental entities and others kind of sharing their data and learning from it. Whether it's just borings all around.
Hmm.
A lot of our these teams have a lot of data that's s- just there, and
Yeah,
it's not being really used to its optimal capability. So I'm hoping to see kind of AI bringing that data, and because right now you need so much manpower in order to process it, just taking
yeah.
it all and giving us some new insights about what we might have been missing. So I'm really looking forward to that. And And I'm looking forward to the regulations keeping up with the technology, like you
Mm-hmm.
per the most previous question. And if you want to reach me, and you can find me at a lot of these committees that I mentioned, construction events, or you can contact me directly by email.
Awesome. Fantastic. And before we turn it over to you, Matt, to close us out, we do have one question that we got here. Awesome. Thank you, Paul. So, when you're monitoring using drone LiDAR, are you essentially creating comparison surfaces using the point clouds?
Exactly. That's exactly what we're doing. So you go, you fly the drone. You have the different payloads. So you take the photogrammetry one out, you put in the lidar, and you fly it. So you set your own control points with the drone as well, and it does photogrammetry and lidar at the same time, that payload. And then you take those control points and you set your point cloud, and then you fly again, and using those control points you tie them in and you compare those surfaces. That's 100% exact.
Okay. Great question. All right. So, last but not least, Matt, what are you excited for and where can people find you?
Okay, yeah. So I'm excited for a couple things. Well, to Ray Ann's point, I think the sensor technology is starting to be astounding. There are multispectral satellites that are being launched or in plans of launch that will give us amounts of data and types of data that we've never seen before to be able to understand what's going on, whether that be geostructurally or even with the Earth itself. So I'm very excited about that, utilizing those different types of multispectral data to be able to understand things. But I'm also excited for, obviously AI is a big topic, but,
Mhm.
what we're actually going to do with the AI. So we're to a point now where we are being proactive versus reactive with monitoring. A lot of folks are starting to proactively put in monitoring before problems exist so that they have a full understanding. But now I think we're moving into the era of being proactive with your data. So what can our data tell us
Yes. Yes.
before something happens? What can our data tell us to keep an eye on as we start to increase the automation of these sensor sets? So I think that technology is what I'm most excited for, being proactive with the data and not just the process. As far
Yeah.
as reaching me, you can reach me on LinkedIn. I'm at several conferences throughout the year as well. So yeah.
Fantastic. Well, that was such a good discussion. I kind of want to, I feel like we should close it out unless there's any last questions or comments. Feel free to add them in. But I would like to give a big, big thank you to Matt and Ryan for sharing your expertise, your knowledge, your true passion, really, for this topic, this industry, and ultimately working on an area that will make us safer and more effective and efficient and is constantly working to transform and improve the way that we build and engineer and work together. So I'm really excited. I learned so much from this discussion as well myself. Had no idea about the history of monitoring. There's definitely a few acronyms in there I'll have to go back and look up. But thank you, thank you, thank you. And then for anybody in the audience, feel free to reach out to our guests here should you have any questions or want to follow up with any of the topics that we discussed. And then the comments will still remain active on at least LinkedIn, so you can still add any thoughts or share any questions that you may have after the event.
It's been a pleasure,
Um,
Aaron. Thank you
Yeah.
for
Thank you
creating the
so much,
space.
Aaron.
yeah, absolutely. Oh, we're getting some reactions in the chat, so we got a thumbs up.
Yeah.
All right.
Wonderful.
Awesome.
Excellent. Well, thank you guys. Take care and have a fantastic and safe week.
Stay well. Thank
Yeah,
you.
you too.
All right.